Hi everyone, this is Sai with Cisco SD-WAN Technical Marketing Team. In today's demo, we're going to take a look at how Cisco Catalyst SD-WAN works with Azure Virtual WAN. Cloud on-ramp for multi-cloud solution helps extend the Cisco SD-WAN connectivity seamlessly to the Azure cloud and do that with high throughput and also deploying multiple instances as part of the Azure region. And doing all of this, we can do it with security in place so that all SD-WAN branch traffic is securely connecting from your branch location to the Azure workloads. Adding on top of that, we have telemetry and various troubleshooting options which will help in your day one operations. Now let's have a look at the demo, see how things work in action. Let's start from the Cisco SD-WAN Manager dashboard and go to Cloud on-ramp for multi-cloud. There are four major steps as part of the workflow. The first one is setting up the cloud account, then discovering the host VNets, and creating the cloud gateways where we deploy the virtual routers as part of the cloud infrastructure, and then finally defining the cloud intent where we map the SD-WAN fabric to the cloud workloads. Let's start with the first step of defining the cloud account and providing the name for our cloud account and defining that we will use it for deploying the cloud gateways and enter the Azure API keys such as tenant ID, subscription ID, details about our client ID and secret key and so on. Then let's click on Add, which completes the association of our cloud account, and then we can navigate to the next step of defining our global settings for our infrastructure that we would be deploying on Azure. Some of the global settings are starting with software version, where we can select the version of the SD-WAN edge routers that we would be deploying. For this demo, we'll select 17.12 version. And then the scale unit is defining the size of the virtual routers that we will be deploying. We can go all the way up to 80 scale units and scale up to 40 Gbps throughput. And then we can define the subnet pool that we would be using for the SD-WAN edge routers that we'll bring up, and the BGP autonomous number. And there are additional settings such as either advertising the default route to the virtual hub or enabling the audit so that there is a periodic check of the infrastructure that has been synced between the SD-WAN manager and the Azure portal. The settings such as software version, scale unit, and subnet pool is something we can also edit while we are deploying a cloud gateway so that we can modify them as needed for each deployment we do across the Azure regions. Once we complete deploying the global settings, now let's go ahead to discovering the host VNets, where we're going to discover the specific VNet within the central US region and tag that VNet as a dev VNet, because that is what we're going to give access to the SD-WAN fabric users so that they have access to these host VPC workloads. Now let's look at entering the tag name as a dev VNet and the region that this particular VNet is located in central US. And now we're going to select add so that the VNet gets tagged as the dev VNet. Once the tagging is complete, before we get to the next step, there's a prerequisite that we have to do is defining the template configuration for these virtual routers that we will spin up in the Azure infrastructure. So let's get to the Azure templates. There's a default template that's offered, and we can also copy that to create this custom template with these additional config options that are required, and then attach these virtual routers and enter the variable values that corresponds to those SD-WAN virtual routers. And this is all the configuration that gets pushed, that gets used for bringing up the virtual routers as part of the Azure infrastructure. Once we click on configure devices, this configuration push goes to a scheduled state, and once the devices are onboarded to the SD-WAN fabric, once the virtual routers are onboarded to the SD-WAN fabric, they get this configuration pushed from the SD-WAN manager. So now let's go back to the cloud on-ramp for multi-cloud workflow and go to the third step of creating the cloud gateway. Let's click on the Create Cloud Gateway option, and we're going to provide various information in terms of the Azure account that we'll be using, and the region where the cloud gateways are going to be deployed, and the resource group, virtual WAN, and the virtual hub that we're going to use, and also provide the information about software version, settings, SKU scale unit that we'll be using, which by default comes as what we have defined as part of the global settings. And once we click on Add, that will then further initiate creating these virtual routers as part of the Azure infrastructure within the virtual hub. Now that infrastructure has been spun up on the Azure, now let's go to the final step of implementing the cloud connectivity. From the Cloud On-Ramp for Multi-Cloud dashboard, we'll select the cloud connectivity in the intent management section and edit the matrix to map the SD-WAN VPN 10 to the host VNet tag that we have defined and save the intent. Now that would push the BGP configuration to the cloud routers and also define the host VNets that needs to be associated with the virtual hub. So now let's look at the CLI configuration on the SD-WAN edge routers to make sure the routes are learned over the BGP from virtual hub and are also installed as part of the VRF10 routing table. So these are some of the CLI commands using which we can now look at all the routes that are learned over BGP and also the routes that are installed as part of the VRF10 routing table, where we see the host VNet routes are learned and installed. In the Azure portal, we can see the virtual hub that we have used under which the Cisco SD-WAN NVAs are spun up, and look at the virtual network connection that has been established in order to connect to the host VNets. And here is the network virtual appliances that are spun up under the virtual hub. And now within the virtual network connection, what we're going to do is delete the virtual network connection to simulate a scenario where, for example, a CloudOps user could have deleted a virtual network connection by mistake. And now go back to the SD-WAN Manager dashboard and trigger audit functionality, using which SD-WAN Manager tries to pull all the infrastructure elements that are existing right now on the Azure and compare that with the intent that we have defined. And if there are any differences that are found as part of that discovery, they will notify that these are the things that are out of sync, and user can select that particular for example, in this case, mapping that is out of sync, and click on Fix Sync Issues so that SD-WAN Manager will make those API calls back to Azure again in order to get the virtual network connection created. And now if you go back to the Azure portal, in a few minutes, we will see that the virtual network connection has been established back. Now let's go back to the Cloud On-Ramp for Multi-Cloud dashboard and click on the Cloud Gateway, where we can look at some of the monitoring stats such as TX and RX in terms of how much traffic is going through the SD-WAN routers, and also look at all the associated SD-WAN branch locations. And for example, here we see with the data center in San Jose location, there is an issue with the connectivity, which user can debug further. And we can also look at all the host VNets that are associated with the SD-WAN fabric and in which VRF those host VNets will be accessible to. And for a specific SD-WAN virtual router, there are system-specific dashboards which offer visibility into various health metrics such as CPU and memory utilization, and also interface dashboards to look at the amount of traffic that is going through various interfaces. I hope you enjoyed watching the demo. Now please go ahead and scan the QR code to get access to our lab environment where you can try On-Ramp for Multi-Cloud with Azure Virtual WAN in a lab environment and learn more about our solution. Thank you for watching this demo.